Hello everyone, and welcome to the Complete Python Programming course. In this video, we'll talk about how Python works. This video is part of the intermediate level tutorial. Python is an interpreted language. The way Python works is highly involved with how Python manages memory. This is one of the most important lessons in the entire course. We will use as many examples as possible in this lesson. Let's get started. If name equals main, a equals a. A is just a string, and we will print ID of a. In Python, the ID prints the memory address of a variable. Let's run our code. And Python printed a string or an integer to my screen. We can access the hex address for that, for people who are used to seeing it in hex, by wrapping it in hex. We run that, and Python returned the hex address of a variable. Before we continue, let me just write a function here, def, let's call it mem, and this function just take a variable and it prints to the screen. Print if string, let's just print the hex, the ID of the variable, just to make our lives easier. Instead of typing all that every time, we can just write a function here. Type, let's go with type of the variable as well, type var, and let's also go with the value of the variable, and var. Let's run our function to see if it works, and mem, let's run that, and it does work. It prints the hex address of the variable, the type of the variable, and the value of the variable. Now this is straightforward. Let's create another variable, b equals b, and let's print b as well. And as expected, we have two different memory addresses because we have two different variables. Let's change this b into b equals a. This looks like a reference, and let's print that. And it might be or might be not what you expect. It's actually just the same memory address for both variables. Let's take this one more step. C equals another new variable. I will give it a value of a. Let's print C. Clear. And run our code. And notice that the three variables printed the same memory address. For a and b, all right, but for c, that's a new variable, and we passed it a new value. Its value is a, and it has the exact same memory address as a and b. Let's get rid of b for now, or yeah, let's get rid of b to work with a and c. So at this point, we have two variables. They have the same value, but they also have the same memory address. This is how Python uses objects to store values. You hear people say that everything in Python is an object, and that's absolutely true. Python, when you try to assign a to the value of a or whatever other value, if you change this to any other value, it will actually return the same result. Let's see that just to make sure that we are on the same page. Python searches its memory. If it has an object matching what you are declaring, it will actually use that. Otherwise, it will create a new one. In this case, Python first created the object. It's a string. It's an array of characters, and Python found that it doesn't have hello, so it created it. When you try to declare C is actually equal to the value of A, and Python just assigned C to the same address of A. Let's see one more example to see how that works. S equals A. That's a string, that's an integer, equal 5. That's a float, equals 20.6. That's a list, and in our list, let's add an A, a 5, and 20.6. Let's create also a dictionary, and let's add 3 values at index. Let's just use numerical indices, and let's add an A in here, and a 2, let's add a 5, and a 3, let's add 20.6. Let's print these. Mem A, that's an S. Mem I, mem F, and mem D. That's an L first, and the last one is mem D. Let's print these and see what Python returns. Clear and run our code, and as expected, there are 5 different memory addresses to hold our 5 different variables: string, integer, float, list, and a dictionary. Let's see about the list first, and let's print the values at index 0 and 1 and 2. We run our code, and our 3 values are exactly identical to the variable S, I, and F. The S ends with FO, this one is ending with FO. It's exactly the same memory addresses. What's happening in there? Python found that it already has an A. When we try to assign A as the first value of our list, Python found that it has an object with a value, a string object that its value is an S, is an A, and it just used that and added a reference here to the memory of that address, of that variable, that data, let's say. Now, in the case of 5, it did exactly the same. It has already a 5, and it used that instead of creating a new variable in memory or a new slot in memory. And the same for the float. That might be very different from what you saw in different languages. If you are working with lower level languages, you control the memory. Whatever you put, it will be in the memory if you add it to the memory. In Python, it's different. Now, let's see something else about the dictionary and see if the dictionary actually corresponds to that. 1 and 2 and 3. And let's run our code. Let's clear the screen and run our code. And also, the dictionary had the same values. The float values, it's this one, and it's this one, and it's this one in the 3 cases. The string value is this one, and it's this one, and it's the same in all cases. And the same for the integer. It's the same value in the 3 cases. Everything in Python is an object, and the object is what controls how Python actually works when you add variables or you assign new data or whatever. We'll see more examples with that in a minute. Let's go for a little bit something different. Print ID of 2 plus 7. Print the ID of 9 and print, let's create a variable here, I equals 9, and let's print the ID of I. Now I'm just printing the ID of 2 plus 7, the ID of 9. I'm creating a variable after I print the first 2 values, and then I'm printing its ID. Let's see what happens if we run this code. And my 3 IDs, my 3 memory addresses are exactly the same. In the first case, I asked Python to add 2 and 7 and return the result. Python created a variable for that, and set its value at 9 and return the ID of that 9. In your program, it found that it needs an ID for a 9. It already has a 9, so it returned the ID of that one. And when you created the I equals 9, it already has a 9. So it used that, and when you printed it, it's exactly the same. Let's take this a little bit more further than that. L equal an empty list. For I in range 1 million, L append I. After that, I would like to print the ID of L. Actually, I will use the mem in this case. We have the function mem L 10. And let's print 100,000. Let's take here some arbitrary number 1, 2, 3, 4, 5. Let's print that and see what Python returns. We run our code and notice that I have 5 or 4 different memory addresses. The first 2 are integers, and because their value is small, it stored them somewhere in the memory. But after that, we have a little larger numbers, but everything has its own memory address. Let me change that a little bit and just change this value to some kind of a string. Let's try A. Let's run this code and see if it's any different than the first one. And notice that the values or the memory addresses of each value in my list is actually the same. I have 1 million. I ask Python to create 1 million, to add 1 million values to my list, and it just created 1 and added it to my list. It's not 1 million, it's just 1. This is very different than what you do when you create something in other languages, because it already has an A. Once it created the first one, it has an object A, and its value is A. The value is A. Whenever it needs to add a new one, instead of creating the new object, it's actually just used the object it has, and it kept a reference to that. Now, you might think that this makes Python so much memory efficient, much more memory efficient than lower living languages, where you actually put 1 million values in the memory. And that will be wrong, because Python has an overhead to keep all that. Now, if you run this program in this language, in Python, and you try to run this with a lower level language, C or C++, you will notice that Python uses way much more memory than these languages, because the overhead of keeping that is much higher than storing this in the memory. So don't assume that just because of that Python is much more memory efficient than lower level languages. Let's take this to a different example. Python makes big distinction between mutable and immutable objects. Let's see the difference between a mutable and immutable. Let's create a function here, def change str, change a string. This function takes a string, and let's just print the string here. Let's just go with before change, and let's print its value s, then s equals, let's change value to hello1 and print after change s, and let's run our function with s equals hello and print before, the word before, s, and run our function, change string s and print after s. Let's run this code and see what it does return. Now, this is how we run our code. Before hello, in this case, is the value hello. Now we go to the function, and before change, it's hello. After change is hello1, and here after it's just hello. This is because strings are passed to the functions by value, not by reference. Let's see if we can just return the ID of this and see how the ID works. And just take this and put it all over the place. And let's run our code. And notice that in the first, second, and the last statement, we have it the same, except here we have it changed. We passed our string to the function by value. So at this point, it has the same value. That's not a reference. It's a value actually. This is a little bit confusing because when you see it that way, you believe that, all right, you passed an S to the function, and when you printed the ID of an S, it's the same ID that you passed. But this is actually, it passed it by value. But when you passed it to your function, Python found that it already has a string that has a value of hello. Why to create a new one? This is exactly the same as doing something like that. Without involving S in the whole thing, you can just do that and you will get the exact same result. In the three cases is the same. Notice that, and in this one is different. Even if you forget about that, before, that's the value of S, that's the ID of S. Now the ID of hello is actually the same ID of S. When inside the function, when you changed S, you actually didn't do anything to this S, you changed the value to a new value. You actually created a new object. That object has a value of hello and it has a new ID. Now, the difference between mutable and immutable, this is an immutable value. It means that if you try to change it, it will have a new identity because the original identity never changes. Notice that S, in this case, it's always the original identity, the original memory address. When you try to change it, it took a new address in the memory. I hope this is clear, so we can move on and talk about the mutable types. Let's change this to change list. Before change, and let's just call it L to make it just clear. We print exactly the same thing. Let's make our list contain one entry, hello, and an L in here, and an L in here. Change L list. Let's run this code. We'll keep this on the screen so we can see the differences. And once we run, I'm sorry, I have to just do this, append. I'll just append to it L1, and instead of just changing it into a string. We run our code, and notice that in the 4 cases, it never changed. In the first one, second one, third one, after one. So when I passed it, the ID before I did anything is the ID, the original ID, where it was created. After I passed it to my function, it's exactly the same ID. I even added something to it. I appended a new entry to my list, and it still has the same ID. And it returned to my function, and now L is altered because now let me show something here, and let's print L in here, and let's print L in here, and clear and run. And notice that it's the same ID, although it looks different. It has a new value. It has hello1 after hello, but it is a new value. but the ID, which is the identity of my list, is not changed. And that makes my list mutable. It changes without changing its ID. The exact same things go for dictionaries. Dictionaries are immutable. You can change them without changing their identity. Now, in this example, even if you try to do something like even just changing the value of hello, changing the value at 0 equals hello 1, that will also return the exact same result. The mutability doesn't change. Lists are mutable, and no matter what you do, they will always have immutable properties. Now, everything is in Python as an object. That's what to remember. And the object type is the important. The identity of the object is the most important part of all that. I hope that this is clear enough. Try all these. If you have any questions, leave a comment. I will try to get to them as soon as possible. Anyway, this is not to start a debate or anything. Python is good for what it does. It's always good to choose the right language for the job you are doing. If you are doing something that's memory intensive and you need to use last bit of memory, you really need to go with something else. If you want something very efficient where you can write your code very quickly and run it without worrying too much about memory or CPU, Python is a good option. So I hope you like this lesson. If you like this video, please support the channel by subscribing. And until next time, have a great time.